In this problem, we are asked to find the distance that a block travels down a frictionless incline with an angle of 12 degrees to the horizontal using work and energy. The block we know starts from rest, and its final velocity after traveling a distance is 1.4 meters per second. First, we'll start by doing a free body diagram of the object. We will use an incline with force of gravity going down, the normal force going perpendicular to the surface, and the direction of motion is to the right. To do this with work and energy, we will use the big ugly, and the big ugly is W force of friction plus W force of tension plus W force applied plus variable forces is equal to the change in kinetic energy plus the change in potential energy due to gravity plus the potential energy elastic. There is no force of friction, force of tension, applied force, variable force. So for each of these non-conservative forces, we can cross these all out. Since the block is in motion, there is kinetic energy, and since there is a change in height, there is potential energy due to gravity, and there is no springs, so there is no potential energy elastic. So we can cross that out as well. So we cross those out and we have 0 is equal to the change in kinetic energy plus the change in potential energy of gravity. Expanded out, this looks like 0 equal to 1/2 mass times velocity final squared minus 1/2 mass velocity initial squared plus mgy final minus mgy initial. We will add these over to the other side such that we get 1/2 mass times velocity squared plus mass times gravity y initial is equal to 1/2 mass velocity final squared plus mass times gravity y final. We see that there are masses in all of the variables, so we can divide those all by each other and cross those out. Those will cancel. And we are left with 1/2 velocity initial plus gravity y initial is equal to 1/2 velocity final squared plus gravity y final. We know that the block is starting from 0 meters per second, starting from rest, so we can cross that out. And if we set our origin to the top of the block where it starts, its y initial will also be 0. So then we'll be left with 0 is equal to 1/2 velocity final squared plus gravity times y final. We will then subtract this over to get negative gy final is equal to 1/2 velocity final squared. And we want to get y final alone. So we will divide this negative g over, and we'll get y final is equal to velocity final squared over 2g. Now we know the final velocity is 1.4 meters per second, and we'll square that. This negative carries over. It is all divided by 2 times 9.8 meters per second. And that is our y final, which gives us a distance of negative 0.1 meters. So from y initial to y final at the end of the distance is 0.1 meters. And so that'll be negative since it is in the negative direction. But the question asks us to find the distance here. So we have an angle and we have a height, and this is a triangle, so we can use trigonometry. And to do that, we will do sine of 12 degrees is opposite over hypotenuse. So opposite over hypotenuse. And so I kept this value positive for now. And since when we're just looking at the triangle, it'll be a positive value. And so the distance of the hypotenuse here, when we do sine 12, is equal to opposite over hypotenuse. We get 0.1 meters over sine of 12 degrees, and that is equal to 0.48 meters. And so this distance is 0.48 meters down the driveway when the final velocity is 1.4 meters per second.